Hi. So we left off last time talking about what is blood, what are the components of blood, what's a blood type, and how can we test for blood. So let's say we have blood at a crime scene. This can help us answer some questions. What sorts of questions can blood spatter analysis answer for us? Well, here are some, right? Where did the blood come from? What caused the wound that blood came from what direction were they wounded, how were the victim or perpetrator positioned relative to each other or relative to the space, what movements were made after bloodshed, how many potential perpetrators were present, does bloodstain evidence support or refute witness statements, right? So once we've determined that there is blood at the crime scene, we can look at, okay, what pattern of the blood spatter exists, right? This is a type of pattern evidence. Let me try to turn it. Okay, there you go. This is a type of pattern evidence that we can use analysis from to learn more things about what took place at this crime scene. We're not going to get too in depth into this, but there are a couple different types of blood stains. Okay, the first is passive, right? Drops, flows, pools, resulting generally just from gravity acting on an injury, right? And a great example of this is you have a nosebleed, okay? It's just dropping via gravity onto a surface from there, okay? Or you have a wounded finger, you got a cut or something, and it's just dripping down, okay? Very passive. A transfer type of stain is where an object will come in contact with an existing blood stain and leave wipes, swipes, pattern transfers. So they might have a shoe print. There might be a handprint smear or something like that, right? So blood has transferred from one thing to a surface via some sort of vehicle, whether that be a shoe, a hand, a wipe of some sort, okay? That's a type of blood stain as well. And the last, which I guess you might be more interested in, is the projected or impact stain, right? So that's the result of blood projecting through the air from some originating point and onto some surface, okay? So this is where we're really going to get into the spatter analysis, all right? So this is going to be spatter, gushes, splashes, arterial spurts. We're not going to get too much into that for our purposes, okay? So what is velocity? Velocity is a measurement of how fast something is moving, right? You can measure that in meters per second or feet per second. In a car in America, you might measure in miles per hour, okay? So that's velocity. And we can look at a stain and decide, okay, what velocity was this blood moving prior to it hitting this surface, right? Are these low, medium, or high velocity stains? So I'm going to give you a second and decide, are these low, medium, or high velocity stains? Okay, so let's go in order. This one is a medium velocity stain, this one is a low velocity stain, and this is a high velocity stain. Now, what does this mean, and how can we tell in the future, right? So let's start with the low velocity stain here in the middle. Something moving very slow, right? You're going to get these larger pools of blood closer together, right? Something like a nosebleed, right? You're just generally not moving that fast. It is not falling that fast, or there's nothing forcing it out of the body other than gravity, right? So the speed of the blood when it hits the surface is relatively low velocity, so less than 1.5 meters per second or 5 feet per second, okay? It's going to cause droplets that are relatively large in diameter, 4 to 8 millimeters in diameter. This one on the left is a medium velocity blood spatter stain. So it could be caused, for example, by someone getting hit with a blunt object, okay? So if someone got hit with a baseball bat, that could cause a medium velocity stain. The blood hitting the surface is somewhere in the realm of 5 to 100 feet per second, though most common in that realm would be 5 to 25 feet per second. In meters per second, that would be 1.5 meters per second to 7.5 almost meters per second. All right. Notice that in this case, the droplets are smaller in diameter, right? So we're in more of a 1 to 4 millimeters in diameter for the droplets, and it looks more like a spray. Okay. In this last one, the high velocity stain, I mean, it's moving at greater than 100 feet per second, or 30 meters per second. So really, really fast. So this might only be caused, in our case, by a gunshot wound or something. It's going to look more like a fine spray. And because of that, the droplet size is going to be less than 1 millimeter in diameter. So significantly finer as you get into a higher velocity. Another thing that we can look at is the angle of how did it hit this surface. If it hit it straight down, it's going to form almost a perfect circle, all right, with no spines or very few spines maybe coming out, right? And as we start hitting it at different angles, notice what happens, right? The stain gets longer and longer and more elongated, okay? And so you can actually calculate the angle of impact. We will not be doing this, but you could calculate the angle of impact and sort of map out its trajectory by comparing the width of the stain with the length of the stain and doing some trigonometry, okay? So you could then figure out, okay, what angle did it come in at? And then tracing that back. If you have multiple of these, you could trace those angles back to the point of convergence, which is where those blood stains originated from. And so that is a basic intro to blood spatter analysis, which we will be using for crime scenes in our class.